Hey, hello. Really hoped I would be back in. I'm sorry, back in today, but obviously not. Hopefully Friday tomorrow I'll be in place. If the do now is done, let's start checking the answers. If the do now is not done, please see if you can get it fixed up here real quick and hit pause and then play when we're ready. Okay, so when we're ready, perimeter and area of the polygon. Well, three of the sides are pretty straightforward. That diagonal side, got to cut it up. Take a look at a triangle. Again, that 6 and that 8 are going to help me figure out the length of the diagonal side. They're not actually part of the perimeter of that polygon. Right? 6 times 6, 36. 8 times 8, 64. 36 and 64 adds up to 100. Square root of 100. And you get 10. Right? So for the perimeter, we've got 6 plus 4 plus 10 plus 12. Again, notice I only use the numbers that are on the exterior for those lengths. I'm not using the numbers I use to try find that length of 10. Those added up to 32. Now for the area, since I've already cut it up into a triangle and a rectangle, I can figure out the area of the rectangle. I can figure out the area of the triangle. Coincidentally, they both happen to be 24. So the total area of that polygon is going to be 48. My hunch is the rest of the do now went pretty quick. 9 squared would be 81. Square root of 36 would be 6. 1 squared would be 1. Square root of 64 is 8. 7 squared is 49. Square root of 4 is 2. 5 squared is 25. Square root of 16 is 4. And 0 squared is going to come out as 0, right? 0 times 0 is 0. Okay, if you can flip your paper over, we're going to do a couple of examples here in a moment. We're going to be taking a look at the prime factorization. Right? Now, a prime number has exactly two distinct factors, 1 and itself. For example, the number 5 is prime because all I can do is 1 times 5. A composite number has more than two distinct factors. For example, 6 would be composite because not only can I do 1 times 6, I can also do 2 times 3. And of course, the number 1 is neither prime nor composite because it only has one factor. Right? 1 times 1 is 1, so the only factor is 1. So again, follow along on your paper, copy the question as it's presented, and then please show the work the way I demonstrate. All right, so we're going to list all factors in order from least to greatest. Then categorize the number as prime, composite, or neither. All right, so before we actually end up doing our prime factorizations, we got to make sure we understand what is a prime number, what is a composite number, what would be neither. All right, so for number 1, please copy down the number 10. All right, question number 1, we're looking at the number 10. Now, I want to make sure I get all the factors in order from least to greatest. So obviously I can do 1 times 10, but notice where I place the 1 in the 10, right? 1 will be the least of the factors, 10 will be the greatest of the factors. I'm helping you out because I've got the blank provided. Later on in the unit, you'll be doing this without the blanks. Now, is there something else that makes 10? Well, sure. 2 times 5 makes 10. So I can list the 2, I can list the 5. Again, I've got the blanks there already to help you make sure that you know if you found them all or not. And now I've got to circle P if I think it is prime. Whoa, we just had a wipe out there. Circle P if I think it's prime, C if I think it's composite, N if it's neither. And of course, I circled C because it's composite, right? There's more than two factors. So I circled C. Now, question number 2. Please copy down 36. Let's see if I can keep things under control here so we don't have the slide jump on us like that again. For 36, well, let's start with 1 times 36. I can place the 1. That's the least of all the factors. Place the 36 as the greatest. Now I'm going to go in order. I'm going to try 2. I'm going to try to figure out if 2 divides into 36. And it does. It happens to be 18. If you aren't too sure about that, use a calculator. Try 36 divided by 2. You'll say, oh my goodness, 18 works. I'll put the 2 after the 1, and I'll put the 18 right before the 36, right? I'm coming in from both ends so I don't miss any factors. Now I'm going to try the number 3. Does 3 work? Yeah, 3 times 12. And this is one you should have memorized from your multiplication table, right? 3 times 12 is 36. Place the 3. Place the 12. Now I'm going to try 4. Yep, 4 times 9 is 36. I can place the 4. I can place the 9. Now, I would try 5, except 36 does not end with a 0 or 5, so I know 5 won't work, right? If you're a multiple of 5, you're like 5, 10, 15, 20, etc. So how about 6? Yeah, 6 times 6. Now, notice that I'm only going to put the number 6 in that list one time, right? I don't list any factor twice. So yes, 6 times 6 makes 36, but I'm not going to put 2 6's in there, right? Just 1. Finally, is this number prime? Is it composite? Is it neither? Well, the number 36, because it has more than 2 factors, it's composite. I'll circle C for composite. 36 is a composite number. For question 3, please copy down the number 7. Well, the only thing that works for 7 is 1 times 7, right? Nothing else is going to work. I've got a 1. I've got a 7. And because there are exactly 2 factors, the number 7 is prime, and I will circle P for prime. Right? 7 is a prime number. The only factors are 1 and 7. Notice that those are 2 different numbers. Right? Students like to think the number 1 could be prime. No, it's not. Because with number 1, you can't get 2 different numbers. For 4, please copy down 64. Again, start with 1 times 64. You'll start to notice that the first number in the list is always the number 1. And then for any of these lists, the last number is always the number we're working with. Okay, now go in order. Try 2. Aha, 2 times 32 makes 64. Place the 2. Place the 32. Now I'm going to try the number 3. If need be, grab a calculator. 64 divided by 3. Uh-oh, I get a decimal answer. 64 does not divide evenly by 3. Okay, skip that. Let's go to 4. Ah, 64 divided by 4 is 16. I can place the 4, place the 16, and then the last one, quite obviously, 8 times 8 makes 64. Right? I could have tried 5, discover it doesn't work. I could have tried 6, won't work. Could have tried 7, won't work. 8 times 8 makes 64. There are more than 2 factors, so 64 is composite. For number 5, please copy down the number 49. You want to challenge yourself and try to list the factors before I do? Again, at any point, if I'm going too fast, we can always hit the pause button, right? Or you can rewind if you need to. Well, 1 times 49, place the 1, place the 49, and then, of course, we've got 7 times 7. That number is composite because there are more than 2 factors. Again, today I've got the blanks there so you know when you're done searching. In a future lesson, you're just going to have the number and you're going to have to make the list without knowing how many factors you're looking for to start with. Right? Today, though, it's like, hey, for number 6, I know there's only 2 factors because the teacher only left 2 blanks. The only thing I can do with 13 is 1 times 13. And because that's exactly 2 factors, I know it's prime. Right? So if there's more than 2 factors, we circle C for composite. If there are exactly 2 factors, we circle P for prime. And if there were only 1 factor, then we would circle N for neither. Obviously, you're not going to be circling N very often. Okay, let's start working independently. Besides practicing finding factors and deciding if a number is prime or composite, you'll notice that there's also some practice of previously learned material that's available. Oh, hey, you're back here. You've done some of the work. And now I'm thinking I might have misspoke on the previous side that you might not have had some other practice available, right? You're like, hey, what am I supposed to do with these things? Okay, so we're going to make factor trees. Then we're going to write the prime factorization. You're like, what on earth are those? I hope you've already seen a factor tree in a younger grade. Hopefully you've seen a prime factorization before, but if not, that's why I'm doing this right now. Right? So first you're just going to actually watch. You're just going to look while I do a couple examples, right? You don't have to copy these down. You just want to watch. And then when you do get the next worksheet, I will actually help you get started, okay? But just watch and listen. Number 20. Okay, so I got to make a couple branches. Right? So I'm going to explore the number 20. I'm going to make 2 branches. Now, I'm not going to do 1 times 20 because I'd still have a 20. So you could write 2 times 10. You could write 4 times 5. Right? So I need a pair of factors whose product is the number above it. I'm going to do 4 times 5. 4 times 5 is 20. I've started my factor tree. Ooh, 5 is a prime number. I'm going to circle that. Right? The only thing that makes 5 is 1 times 5, so that is the end of that branch. Now, the number 4, however, I'm going to draw branches underneath that. 4 is a composite number. 4 can be rewritten as 2 times 2. 2 is a prime number, so I'll circle each one of them. Now, if you are curious, and you're thinking, well, what if I started with 2 times 10 instead? Right? Because some of you didn't want to do 4 times 5. Some of you might have wanted to do 2 times 10. Well, if you start with 2 times 10, you'd circle the 2. Underneath the 10, you draw branches, and you do 2 times 5. 2 is a prime number, I can circle it. 5 is a prime number, I can circle it. So your factor tree might not look like mine. Your factor tree might not look like the scholar sitting next to you. But notice on each factor tree, the smallest number I circled was 2, and I circled 2 of them. I also circled a 5. So either factor tree, even though the trees look different, I have the same prime numbers circled. I circled the number 2 twice. I circled the number 5 once. And so the prime factorization is 2 squared times 5. Right? With either tree, that's my result. That's my answer. 2 squared times 5. Right? In other words, 2 times 2 times 5 are the prime factors that create 20. Right? So the answer, called the prime factorization, is 2 times 2 times 5, but we will write that as 2 squared times 5. Notice I put the smaller number first, so I started with the 2. Also notice that we like to use dots for multiplication. If you want to use the old-fashioned multiplication symbol, you can. Higher up you go in math, less and less often will you see that symbol for multiplication. So you need to show the work for the tree, and then you need to write the prime factorization. In this case, the answer is 2 squared times 5. Again, just keep watching for right now. Just watch the next couple examples, then I'll help you get started. 15. Well, what can I do? 3 times 5. I mean, I don't have any other choice. I circle the 3 because that's a prime number. Circle a 5 because that's a prime number. The answer is just 3 times 5. Right? 3 times 5 is 15. 3 and 5 are both prime numbers. There's the answer. 48. Oh my goodness, we can have all sorts of different trees for this one. Right? What numbers do I want to start with? Well, maybe you're going to go organize and keep trying 2. Say, hey, 2 times 24. Circle the 2. How about 24? 2 times 12. Circle the 2. How about the number 12? Well, for 12, I can do 2 times 6. Circle the 2. How about the 6? Well, I can do 2 times 3. Circle the 2. Circle the 3. Now, the smallest number I circled was a 2, and I circled 4 of them. Right? Then I also circled a 3. So I have 2 to the 4th power times 3. Now, again, keep watching because I'm going to show this one again with a very different tree. I could have said, no, I'm not going to start with 2 times 24. I'm going to start with 6 times 8. 6 is a composite number. I can put branches underneath it. Right? So 6 is 2 times 3. Those are both prime numbers. Circle both of them. 8 is 4 times 4. Circle the 2. 4 is a composite number. Let's draw some branches. 4 is 2 times 2. Circle the 2's. Now, that tree looks very, very different. But notice the smallest number I circled was a 2, and I circled 4 of them. The other number I circled was a 3, and I only had 1 of them. So my answer is 2 to the 4th power times 3. Right? So the trees may look extremely different, but we're going to get the exact same answer. Okay, so now we got to get the next worksheet passed out, and I'm going to actually help you on the first 3 questions. So this might be a time where you have to pause the video, right? Hit the stop button, the pause button, do. Make sure everyone has a copy of the next worksheet, do. And then when people are ready, you can hit play, and we'll start looking at the first 3 questions step by step. Okay, assuming we're ready, let's get going. First one on your paper is a 45. So again, I got to put branches underneath it. After I make the branches, I got to think, okay, what times what makes 45? Hopefully you've got your multiplication table memorized and say, oh yeah, 5 times 9 is 45. right? Those multiplication facts that you needed to memorize back in elementary school, they never go away. No matter how high you go up in math, you will always need to have those multiplication facts memorized. Makes life a lot easier. 5 is a prime number. I can circle it. 9 is composite. I'm going to draw branches. 9 is 3 times 3. Circle the 3 because they're prime numbers. Okay, every branch has been finished. The smallest number I circled was a 3, so I'm going to put that first. And I circled 2 of them, so I'm going to have 3 squared. And then after the 3 squared, I'll put times 5 because I also circled a 5. So there's a tree, and there's the answer written as the prime factorization. 3 squared times 5. That's the answer. Next tree, well, it's a 40. What should we start with? Want to challenge yourself and try to put something down before I do? I'm going to start with 4 times 10. If you started with 5 times 8, you'll get the exact same answer. Underneath the 4, I can do 2 times 2. Those are prime numbers. I can circle them. Underneath the 10, well, 2 times 5 makes 10, so I can put a 2 and a 5. I'll circle those. If you started with 5 times 8, you would have circled the 5. And then underneath the 8, you could have done 2 times 4, circling a 2. And then underneath your 4, you'd have a 2 times 2. And you say, oh my goodness, I'd have the exact same result, right? Either way, the tree should have the smallest number circled as a 2, and you should have 3 of them. So I'll have 2 to the third power, right? The number 2 is the smallest factor. I had 3 of them, so it's 2 to the third power. But I also circled a 5, so I put 2 to the third power times 5. That is the answer written as a prime factorization, right? Those are the prime factors that multiply to get 40, right? 2 times 2 times 2 times 5 makes 40. So that's 40 written as a bunch of prime factors. Next one is 30. Do you want to challenge yourself? Try to make the tree before I do? I'm going to start the tree by doing 5 times 6. You might have started with 3 times 10. You might have started with 2 times 15. I start with 5 times 6. Circle the 5 because it's a prime number. Put branches underneath the 6 because it's composite. 2 times 3 is 6. Those are each prime numbers. Smallest number I circled was a 2, but I only circled one of them. Next smallest number was a 3. I only circled one of them. I also circled a 5, but only one of them. So the answer is 2 times 3 times 5. Notice I put those in order from least to greatest. 2 times 3 times 5. Those prime numbers multiplied together make 30. That's why we call that the prime factorization. 2 times 3 times 5 makes 30. Okay, now with this worksheet, time for some independent practice. Start working. And you should find on the back side of this worksheet, there's some practice of other skills that we worked on with this unit. Have fun, get some math done, and I will really try to be back in the building on Friday. I apologize for not being there. I enjoy working with you. I enjoy teaching math. I enjoy doing math. Some of you do a great job every single day. All of you are capable of doing great work, though, and that's what we need to work toward. Have fun, get some work done.